Hey guys, how are you doing? We're going to continue with trigonometry. We finished section 13-1, which is just periodic functions and what a cycle was and the length of the period and what the amplitude is. These are all going to be important when we start graphing trigonometry functions like sine, cosine, and stuff like that. Right now, we're going to talk about something that's really important also, and it's special right triangles. I did mention it one time on bell work once or twice, special right triangles. There's two special right triangles. At this time, I'd like you guys to start copying these notes that I have on this notebook that I copied down. This is actually page 717 of your book. So all the stuff you see here is in the book on page 717. It's actually not one of the sections. It's between section 13-1 and 13-2. So it's right after 13-1, which we just finished, which is periodic functions and cycle, period, and amplitude, and what those things mean. And we're going to be applying those later on. Special right triangles are really important because there's a relationship between the side lengths. And there's two special right triangles. The first one is the 30, 60, 90 that I'm going to talk about. And we name special right triangles by their angle measurements. And these relationships between the side lengths only work with these two triangles. A 30, 60, 90 triangle is a right triangle that has a 30-degree angle, that's the smallest angle, a 60-degree angle is the middle, and a 90-degree angle, the right angle. And there are three sides here also to this triangle, and they all have a name. The short leg is the shortest of the three sides. That's why it's called the short leg. And you can summarize it by saying SL for short leg. The long leg is the middle of the three side lengths. The hypotenuse is the longest. Always the hypotenuse is the longest side of any right triangle. So the hypotenuse is the longest side. The short leg is the shortest. The long leg is the middle. And how you find them is the hypotenuse is always the side that's opposite the right angle. Here's the right angle. Opposite is the hypotenuse. That's the hypotenuse right there. The short leg is the side that's opposite the shortest angle, which is 30 degrees. The short leg is opposite the shortest or the smallest angle, 30 degrees. The short leg is going to be right here, opposite the 30-degree angle. The long leg is the side opposite the 60-degree angle. That's how you identify them, because they're not going to all be drawn like this. They can be drawn upside down or in an angle, anything like that. Okay, so I have it written here, which one is which. Here are the relationship between the side lengths of all 30, 60, 90 triangles. The hypotenuse is 2 times the short leg. So if you know the short leg, to find the hypotenuse, you just multiply the short leg by 2. What if you know the hypotenuse? How would you find the short leg? Well, you do the opposite. You divide the hypotenuse by 2. It makes sense, because if you're starting with the short leg and you want the hypotenuse, isn't the hypotenuse bigger? So shouldn't you multiply by 2 to get it? And that always works with 30, 60, 90 triangles. So and vice versa, if you know the hypotenuse and you want the short leg, you simply take the hypotenuse and the short leg is smaller, so you have to divide by 2. So you're multiplying or dividing by 2 between the hypotenuse and the short leg. Okay, the relationship between the short leg and the long leg is different. The relationship between the short leg and the long leg is the square root of 3. And it should make sense what either you're going to divide by square root of 3 or multiply by the square root of 3. Okay, let's say I knew the length of the long leg and I wanted to find the short leg. I would take the long leg and either multiply by square root of 3 or divide by square root of 3. But since the short leg is getting shorter, I'm not going to multiply by the square root of 3. It's going to make it bigger. So I'm going to divide by the square root of 3. So if you know the long leg, to find the short leg, you simply divide by the square root of 3. Short leg equals long leg divided by square root of 3. Okay, and vice versa, if you knew the short leg, the length of the short leg, and you wanted to find the long leg, you would multiply the short leg by the square root of 3 to find the length of the long leg, because the long leg is longer than the short leg. That makes sense. So here in C it says long leg equals short leg times 3. This is the relationship here that I want you to copy down and memorize. The other special right triangle we talked about in bell work is the 45, 45, 90 right triangle. Again, it's named by its angles. And it's an isosceles right triangle. because it has the base angles are both 45 degrees, which means these two legs are always going to be congruent to each other. They're always going to be equivalent to each other. So in a 45, 45, 90 triangle, the hypotenuse is the side opposite the 90 degree angle, the right angle. And the legs are the sides opposite the 45 degree angles. Since they're both the same angles, these lengths will always be equal to each other. Therefore, it's a isosceles triangle. So here's the relationship between these side lengths in any 45, 45, 90 right triangle. And the relationship is always the square root of 2. Given one, you can find the others by either multiplying by the square root of 2 or dividing by the square root of 2. So, for instance, if I know the hypotenuse, the length of the hypotenuse, if I want to find either of these two lengths, I would either multiply by the square root of 2 or divide by the square root of 2. But we know that these legs are shorter than the hypotenuse. Therefore, given the hypotenuse, I would have to divide by the square root of 2 to find the leg, because it's shorter. You divide by 2 to get the smaller side, square root of 2 to get it smaller. If you want to make it bigger, you'd multiply by the square root of 2. So again, hypotenuse is equal to, the other way around is, if you know the legs and you want to find the hypotenuse, you would have to multiply the leg by the square root of 2 to get the hypotenuse, because it got bigger. Look, here we go. A, the hypotenuse is any leg, because they're both the same. To find the hypotenuse, you take any leg, the length of any leg, and you multiply that number by the square root of 2 to get the hypotenuse. Okay? And vice versa, if you know the hypotenuse and you want to find the leg, the length of a leg, of any leg, any one, because they're both the same, you would take the hypotenuse and divide it by the square root of 2. These are your special right triangles. There's only 2 of them. Okay, so example 1 is asking us to find the missing legs given these 2 triangles. So go ahead and copy those 2 triangles, and we're going to find the missing legs. This one, the legs are given to as 5 and 5. The missing side is h. This happens to be the hypotenuse because it's the side opposite the 90 degree angle. It's the longest side. Well, to find it, I'm either going to multiply by the square root of 2 or divide by the square root of 2. In this case, since the hypotenuse is the longest side, I'm going to multiply by the square root of 2. So therefore, I'm going to take the short leg, which is 5, to find the hypotenuse. The short leg 5, I'm going to simply multiply that by the square root of 2. And the answer is 5 root 2. Again, if you put it in your calculator, you'll get a decimal answer, but this is the exact answer. Either one's fine. I want the exact answer. B says, given this length 5, find these 2 lengths. Well, what is this length first? I got to identify if it's a short leg or is it the hypotenuse first before I do anything. This happens to be what? The hypotenuse, correct, because it's the side opposite the 90 degree angle. Well, given the hypotenuse, how do I find the short legs? Well, the short legs are shorter than the hypotenuse, so I'm either going to multiply by the square root of 2 or divide by the square root of 2. Since it's shorter, I'm going to divide by the square root of 2. So to find S, and again, if I find S, it's going to be the same for both because it's a isosceles triangle. To find S, I'm going to take 5, the hypotenuse, and divide it by the square root of 2. And if I divide them, I'm going to get a decimal answer, but I want the exact answer, so I'm not going to actually divide them and get a decimal answer. Therefore, what I'm going to do is, I'm going to go ahead, this is going to be the answer, but remember, we have to rationalize the denominator. We can't have a square root in the denominator. So I got to continue by rationalizing the denominator. To rationalize the denominator, remember, we simply multiply the denominator by the square root of 2 to get rid of the square root. But wherever you do the denominator, don't you got to do that to the numerator also? So right now I have the answer as 5 divided by the square root of 2, but I can't have a square root in the denominator, so I have to rationalize that denominator. So here's how you do it. Multiply top and bottom by square root of 2. It's the same as multiplying by 1. So if I do that, in the denominator, I'm going to get square root of 2 times square root of 2 is equal to the square root of 4, and the square root of 4 equals 2. In the numerator, 5 times the square root of 2 is just simply 5 times the square root of 2. And this is your final answer because I can't simplify any further. Okay? Without further ado, I want to go on to example 2, which is 30, 60, 90 right triangles and finding the missing sides. So let's go ahead and do that now. I'm going to turn the page over. Make sure you copy everything down. Turn the page over. And then here's example 2. Make sure it's centered right. Yep, it's example 2. Again, we're continuing special right triangles. And it's same page, 717 of your book. And given this triangle here, 30, 60, 90 right triangle, okay, they give you this side length is 4, this is missing, and this is missing. H and S are missing. Well, the first thing we gotta do is identify which side is which. The shortest side is called the short leg. How do I know it's the shortest side? Well, it looks the shortest. Not only that, it's opposite the 30-degree angle. The middle side is called the long leg, and it's 4. How do I know that's the long leg? Because it's the side opposite the 60-degree angle. So 4 is the long leg, S is the missing side, short leg, and the hypotenuse is H because it's the side opposite the 90-degree angle. It's the longest of the 3 sides. Side opposite the 90-degree angle is the hypotenuse. Okay, let's look at these 3 notes that I want you to copy down. Hypotenuse is the longest side, side opposite the right angle. Long leg is the middle length, side opposite the 60-degree angle. I just talked about that. And the short leg is the shortest side, side opposite the 30-degree angle. I just talked about that also. Okay, we want to find H and S. H happens to be the hypotenuse. S happens to be the short leg. So I got to find both of these in example 2. Okay, let's go ahead and do that. If I'm finding H, remember the relationship is, if I know the short leg, all I have to do is multiply the short leg by 2 to get the hypotenuse. But guess what? I don't know the short leg. So guess what? Right now, I have to find the short leg first before I find the hypotenuse. So I'm going to go back over here and try to find the short leg first. Because the relationship between a 30, 60, 90 triangle is the hypotenuse is double the length of the short leg. But I don't even know what the short leg is. So let me find the relationship between the long leg and the short leg first. And when I find that, I can apply it to find the hypotenuse. So the long leg and the short leg, the relationship is square root of 3, remember? To find the short leg, doesn't the short leg get smaller than the long leg? So I'm either going to multiply by the square root of 3 or divide by the square root of 3 to find the short leg. In this case, since the short leg is shorter, I'm going to take the long leg, which is 4, and I'm going to divide it by S equals the square root of 3 because it got shorter. Well, there's your answer. If I divide it, I'm going to get a decimal answer. We don't want the decimal answer. I want the exact answer. So I'm going to keep it in root form. Well, if I look here, I have to rationalize the denominator. Remember, I can't have a square root in the denominator. So simply, to simplify this, I'm just going to rationalize the denominator by multiplying the numerator and denominator by the denominator, square root of 3. If I do that, I'm going to get 4 times the square root of 3 in the numerator, 4 times square root of 3. And the numerator square root of 3 times the square root of 3 equals the square root of 9, which is equal to just 3. There's your final answer for the short leg. Now that I have the short leg, I can apply it here and find the hypotenuse. Didn't we say the hypotenuse equals the short leg times 2? So that's what we're going to do here. Hypotenuse equals, the short leg is 4 root 3 over 3 times 2. Well, when you're multiplying a fraction times a whole number, you got to make that whole number a fraction and multiply. If I multiply the numerator, I'm going to get 2 times 4 is 8 root 3, and 1 times 3 is 3. There's your final answer for the hypotenuse. So I found my hypotenuse and the short leg. Okay, let me go ahead and do the extra examples in 7-7, which is your part of your homework. Your homework is going to be 1 through 14 all, page 717. And let me do number 1 and 6 for you, and you guys can do the rest. Number 1, given the hypotenuse is 1 inch, and number 1 happens to be a 45, 45, 90 triangle. That's what it told us in the notes, in the actual directions. So let me go ahead and draw this. I know it's a 45, 45, 90 triangle. This is what I want you guys to do in your homework. Okay, the hypotenuse is 1. The hypotenuse is the side opposite the 90-degree angle. That's 1 inch, which means I have to find this side and this side. They're both going to be the same. It's an isosceles triangle. So let me go ahead and do that real quick. The relationship is the square root of 2. Since the side is getting shorter, I'm going to divide by the square root of 2, divide the hypotenuse by the square root of 2. Okay, and then if it was the other way around, if I was given the side length and asked to find the hypotenuse, I would multiply the side length by the square root of 2. So it's either divide by the square root of 2 or multiply by the square root of 2, And it's pretty simple to figure that out because if the side gets shorter, you're dividing by the square root of 2. If it's getting longer, you're multiplying by the square root of 2. And again, given the hypotenuse, I know the short leg is shorter, so I have to divide by the square root of 2. So let me go ahead and do that. Isn't the hypotenuse 1? And then I have to divide that by the square root of 2. Good. Now I have to rationalize the denominator, so I'm going to multiply top and bottom by the square root of 2. Remember that? I can't have a square root in the denominator. So 1 times square root of 2 is square root of 2. And square root of 2 times square root of 2 is square root of 4, which equals 2. There's your final answer. The short legs are both square root of 2 divided by 2. Let's look at number 6 now. Number 6 is a 30, 60, 90 right triangle. So we got to draw that. And they all look the same, basically. Depends on how you want to draw it. I'm going to draw it like this. The smallest angle is 30. The middle angle is 60. And the right angle is 90. It's giving me the longer leg is 1 centimeter. The longer leg is a side opposite. Well, this is the hypotenuse first. Let's identify the hypotenuse first. That's H. Side opposite 90-degree angle. Let me make sure it's in the view here. The long leg is a side opposite the 60-degree angle, which happens to be here. I'm going to call that long leg equals 1 centimeter. And then the short leg is a side opposite the 30-degree angle. It's the shortest of the 3 sides. I'm going to call that short leg, and we just don't know what it is. I'll call it S. I'll just call it S for short leg. I got to find H and S now, given the long leg. Well, the relationship we know is the short leg, and between the short leg and the long leg is the square root of 2. The relationship between the short leg and the hypotenuse is times 2 or divided by 2. We don't know what the short leg is, so I'm going to start by finding the short leg, then apply that to find the hypotenuse. To find the short leg, the long leg is 1 centimeter. And the short leg got shorter, so I'm either going to divide by the square root of 3 or multiply by the square root of 3. Since the short leg is shorter, I'm going to take the long leg and divide by the square root of 3. Which is going to be 1, the long leg is 1 centimeter, and divide that by the square root of 3. That's your answer. If you divide it, you get a decimal answer, but we don't want that. We want the exact answer. Remember, we can't have a square root in the denominator, so I have to rationalize the denominator by multiplying by the square root of 3. 1 times square root of 3 is square root of 3. And square root of 3 times square root of 3 is square root of 9. Square root of 9 equals 3. There's your final answer. The short leg is square root of 3 divided by 3, decimal answer. To find the hypotenuse, now that I have the short leg, it's simple. The hypotenuse is longer than the short leg, so I'm going to multiply 2 times the short leg to find the hypotenuse. If I had the hypotenuse and I was trying to find the short leg, I would divide by 2. Okay, so now that I know that, it's just simply 2 times whatever I got for the short leg, which is this, square root of 3 over 3. When you multiply a whole number times a fraction, you got to make it into a fraction. And just multiply straight across. This becomes 2 square root of 3 over 3. There's the answer for the hypotenuse. This is the work I want you to show on your actual homework. I did number 1 and 6 for you. You can just do the remainder, 1 through 14, 2, 3, 4, so on and so forth. Show the work like this. Draw the triangles. Circle your answers. Take a picture of this and email it to me. This is due. We're going to say this is due Friday. So I'm giving you 2 days. Due Friday when you wake up. Hopefully not later than 5 p.m. But whenever you do it by Friday, go ahead and deliver it to me, email, and I will check it. And I will give you a grade. Remember, formative now is 33%, almost 40% of your grade. And summative is 60% of your grade, which makes this homework almost as, worth as much, almost as much as your quizzes and tests. So thank you guys. I'll talk to you guys later. Thank you.